A square has center 3, 4, and one corner at 1, 5. Another corner is at one of these 5 options. Okay. So I'm not even gonna, I encourage you almost always to draw a picture for stuff like this. But this is so straightforward, we can do this without a picture. So the center is at 3, 4, and there's a corner at 1, 5. If we look at the distance between the x coordinates, so if one corner is at 1, then this means this also corresponds to an entire side of the square. And so in going from 1 to 3, you've gone halfway across the square. So there's certainly another corner at coordinate 5. There's also certainly, in going from 5 down to 4, there's also another coordinate. We take one more step. There's also another coordinate corner there. So these 2 points, 1, 5 and 5, 3, represent opposite corners of the square. And of course, it's pretty easy to fill in what the other corners are then. There will be one at 1, 3 and another one at 5, 5. So let's see which of these is an option. 1, 3 is an option. 5, 5 is an option. Did I screw something up? Square has center 3, 4 and one corner at 1, 5. So this has to be a midpoint between the diagonals. 1, 2, 3, 4, 5, 5, 4 to 3. Hold on. Oh my goodness, maybe we draw a picture. Let's swallow our pride. So that's the center. Hold on. Oh, wait, yeah, okay. I know what I was doing wrong. So that has to be a diagonal. So the first point that I wrote down is correct. And the first point I wrote down was it 5, 3? Yeah, 5, 3 is on the square. That's this point here. The issue here is that the square is not, the sides are not vertical. Okay, so there's a little bit more to this than I thought. Yeah, draw a picture. Okay, we could do this by guess and check in multiple different ways, but what might be a nicer way of figuring out what these points are? should I just guess and check? I mean, even just graphically, it looks like that point is 2, 2, which is one of the options. And I could maybe verify that these lengths are the same from 2, 2. And also that that it forms a right angle. So let's just call this xy. This is 1, 5. So p, well, let's call this v and u. So v is 1 minus x, 5 minus y, and u is 5 minus x, 3 minus y. So if x and y are 2 and 2, then v is -1, 3, and u is 3, 1, and these have the same length and are perpendicular. So 2, 2 works. That's by guessing and checking. How might I go through this and try and figure it out, directly? Well, set these equal in terms of not as vectors, but set the magnitude of these equal to each other, and also set the dot product equal to 0, and you might be able to solve for x and y that way. Yeah, this was a bit of a mix-up from the very beginning. As soon as you say square with Cartesian coordinates in a problem, my intuition incorrectly thought of a square that had horizontal and vertical edges, which doesn't have to be the case, right? But the method that I used to find the opposite diagonal was perfectly fine. But then that point is not one of the options given, and the sort of 2 of the other trick points are in fact given. And the thing that indicated to me that it made a mistake was that there were, according to my solution, there were 2 answers given that are correct. So if only one of those were correct, I might have incorrectly checked that immediately. As soon as you draw the picture, you see what the problem is. Draw a picture. Don't do what I do. Draw a picture. As soon as you draw a picture, you see that the square cannot be oriented at a right angle. It's going to be rotated off of horizontal, and that's because you move 4 units across that way, but only 2 units down that way. So the side lengths are mixed up if you do it the way that I thought you were supposed to do it. Anyway, I spent way too long talking about this one. That is the answer, 2, 2. I mean, yeah, you almost tricked me. Thanks for watching.